So you should now be able to see the screen. So today, first of all, before we get started, like to remind everybody we have some upcoming Connect Services webinars that are coming up that you might be interested in. You'll be getting an email on this as well, or you should have already received an email. One of them is on the end of April. We have one on personal mobility with Bentley apps that talks about the various types of phone and tablet products that we offer with Bentley. On the May 3rd, we're offering a session on ProjectWise connection services, and then on 5/10 or April 10th, we're offering a Connect webinar on adaptive learning services. So look for those in your email coming up. So our agenda for today is I'm going to first of all give you a very brief overview of our new Connect Advisor. This is a new piece of software that we provide in all of the Connect-based applications that provides a sort of a one-stop shop for comprehensive learning and support. Then we're going to dive down into the virtual reality stuff. I'm going to give you an overview of what we're doing at virtual reality in the marketplace. We'll talk about the two different types of VR, phone-driven VR and computer-driven immersive VR. Then we'll dive down and talk specifically about what we're doing at Bentley in both virtual reality and augmented reality. And then we'll dive into a demonstration of how you can actually create VR media directly from LumenRT. So Connect Advisor, this is a new tool that you'll begin seeing in all the Connect-based applications. We began delivering this with Connect Update 4, and you'll see a little icon in the upper right-hand corner. When you click this, you get some very interesting access to various types of help and learning content, as you'll see in this little short video. So I can browse through here. I can get access to Bentley Learn content. I can get access to anything I want. If I want to find something about LumenRT, I can type LumenRT and it can give me information from YouTube and what's going on in the Bentley forums, etc. So it's sort of a one-stop shop to grab all of the information that you need in order to take advantage fully of the application that you're using. Okay, so let's talk a little bit about visualization here. So the virtual reality component of visualization is basically just another extension of what we already provide in LumenRT. So if you think about the kinds of visualization things you can do in your CAD system, generally CAD systems provide things like 2D drawings and 3D models. What LumenRT does is to take that and then deliver some very advanced visualization media. So we provide high-resolution images, high-resolution videos. If you're familiar with LumenRT, we also provide these immersive live cubes. And now, with LumenRT Update 2, which was released 2 weeks ago, we also provide virtual reality media. So the bottom line here is that virtual reality is just an extension of the kinds of capabilities that we are going to continue to provide inside of LumenRT in our entire visualization strategy going forward. There's a number of uses for VR and augmented reality. So if you look at this continuum here of the sort of life cycle in engineering, where you sell your idea, then you engineer the product, and then you operate the product. On the front end of this, VR is quite useful in things like client presentations. Most of our major clients in the engineering and construction and AEC, the engineering firms are all, building VR showrooms inside their facilities, as well as providing VR media over the web. And I'll talk more about what some of those things are doing with some examples later on. VR is also quite useful for things like public outreach. So if you're doing public outreach meetings, you can bring VR, and that sort of adds the nice wow factor. You can bring along your Oculus headsets or your HTC Vive headsets and put those on, and customers really, really like that a lot. You can also use these for things like collaborative design reviews. So we're working with the Microsoft HoloLens, where you can actually have a holographic image of the model sitting on a table, and everybody puts on the headset and they can view that in real time. You can also do things like augmented reality, where you overlay virtual reality media on top of the actual construction site here, so you can see exactly where things need to be built or placed. And then finally, on the far end of this, you can use VR and AR for things like training and maintenance. So how does it work? So basically, what happens is we take a scene and then we create a 360-degree panorama of each frame in that scene that we're looking at, either statically by outputting images or videos, or dynamically by allowing in real time 360-degree panoramas to be presented to you inside of your headset. And the way it works is basically you generate a cube map, which basically has 6 different snapshots to it: left, top, front, right, back, and bottom. And then that is then transmogrified into a equirectangular image. So this equirectangular image is really the output that you would generate in order to view these things on your Google Cardboard headsets or your Oculus or Vive headsets. And then what happens is when that thing gets uploaded in the headset will automatically generate a stereo image of that stutters the images so that you get sort of this nice 3D effect. For augmented reality, it works quite very simply, except we add one other element to it, and that is geolocated reality. So in this particular case, the couch is basically a 3D model or a VR model. And in the background, we have the actual photo of where that couch is going to be placed. So you can overlay virtual reality on top of actual geolocated reality. And you're going to see more applications coming out from Bentley on this during the coming months. So let's talk a little bit about the various virtual reality platforms. So there's 2 types of platforms: phone-driven VR. These are virtual reality headsets that work with your phone, as the name implies. So these would include things like the Google Cardboard, the Samsung Gear VR, and there's many, many other variants of these, but those are certainly the 2 most popular. And then we have PC-driven VR. And the PC-driven VR are the one where all the very high-end headsets work, such as Oculus, the HTC Vive, and the Microsoft HoloLens. And there are several significant differences between these 2 types of VR platforms. First of all, for phone-driven, the latency, meaning the time taken between looking at images when you're turning your head, is quite high. So you don't want to generally have a lot of motion or a lot of very complex scenery on that, because the frame rate won't keep up with your head or with what's going on in the scene very well, and it makes for a very low fidelity experience. So generally, for phone-driven VR applications, these are limited to panoramic images and panoramic videos. In other words, canned media, where you're not really allowing the user to walk around inside of the scene, but they can actually look at things. They can change their head, move their head up and down, and see in a panoramic way what you're presenting. On the high end, we have PC-driven VR, and as the name implies, these devices require a very powerful PC with a high-end graphics card in order to operate. So in this kind of experience, this is the one that gives you that very rich, immersive experience, like you're inside of a game world, and you can walk around, you can touch things, you can bring up other kind of content. It's a very rich, dynamic, multimedia experience. So just keep in mind that when we're talking about virtual reality, and when people talk about virtual reality, you need to understand that there's a continuum here, and there's 2 very different platforms for providing these kinds of capabilities. Okay, so let's talk about each of these devices quickly. The most predominant VR device out there today is the Google Cardboard device. It's extremely inexpensive. It's only around $15. It works with both Android and iPhone. Over 5 million units have shipped in this, and there's over 200 apps. The downside of the Google Cardboard is the same downside as all PC-based VR solutions, is that it has a very high head movement latency, greater than 75 milliseconds. And so basically you're limited to sort of low fidelity, low complexity based images. But you can still produce some very interesting, eye-catching things as I will demonstrate later on. A hybrid of the high-end headsets and the Google Cardboard is the Samsung Gear VR. So this is a joint venture between Samsung and Oculus, and they produce a much better VR experience. It's less than 20 milliseconds latency, better head tracking, but you're still limited to the kinds of images and power of an immersive experience that you can drive over a phone, which is to say, for today at least, is pretty much limited to static images and videos. So shifting to the high end, we have the Oculus Rift and HTC Vive. Both of these are very, very similar. They both deliver a very quality high-end VR experience, reasonably priced around $600. Both of those platforms have very great development tools. The only downside, as I mentioned before, is that if you're going to use the Rift or the HTC Vive, it requires a powerful PC with a high-end GPU. So you're going to need, a device like a 980 GTX from NVIDIA or better in order to drive one of these high-end devices. And then finally, we have the Microsoft HoloLens. This is a relatively new device, still mostly in beta today. But one of the great things that it provides is this augmented mixed mode VR. So you can be looking at a real scene and then overlay that with the VR experience overlaid on the top of it. So it uses this really nice holographic 3D rendering style. The downside is it's still in beta. It's probably a year or more away from commercial availability. It has a relatively high cost, greater than $1,000 per headset, because the computer and the GPU is built into the headset. And there are still currently some limitations on the level of complexity you can handle with a Microsoft HoloLens. Today, you're limited to something like 100,000 polygons. They're adding some things in there that in the next release of the product that'll be out this summer, that they say will get them into the million-plus polygon range, which then begins to approach the kinds of things that we can do in the infrastructure space. So let's talk a little bit about the Bentley infrastructure guiding principles as we move forward. So these are some of the foundation principles that we're operating on at Bentley as we develop and introduce VR products. We are committed to supporting both the phone-driven and the VR and PC-driven VR approaches, which means that we will provide capabilities and outputs that will run on your phone or run on the PC. For the phone-driven VR, we're going to focus principally on 360-degree video and low-fidelity walkthroughs. And then for the scene rendering on the desktop or the cloud, we're going to support full VR scene rendering on either of those platforms, meaning that you can generate VR output on the cloud or on the desktop. And you'll also be seeing an introduction of next generation mixed mode augmented reality apps going forward. Okay, hold on a second. I'm getting a thing here. Let me check and see. Okay, sorry. I thought that was a comment from one of the users here. All right, so let me continue on quickly. So we already have some products out in the phone-driven space. So we introduced LumenRT Update 2 several weeks ago, which allows you to output VR-compliant 360-degree panoramas and video generated directly from LumenRT. And you can generate these on your desktop and have them run on your desktop in something like VLC Media Player, which I'll demonstrate, or you can upload and share those 360-degree videos on YouTube, which I will also demonstrate in a moment. For the VR PC-driven, we are going to be supporting on the near term Oculus and HTC Vive. This will be introduced in LumenRT Update 3 in June. We will be offering an open technology preview on this in May, if not sooner, where you'll be able to actually go on, download it, install it on your machine, and then test it and run it with your high-end headsets. Longer term, we've got a project that will be looking at the Microsoft HoloLens later this summer when they introduce the next generation of the device, and so stay tuned for that. Now, there's two things we're going to be offering on the infrastructure VR, or PC-driven VR, as we like to call it. First of all, it'll have a much richer immersive experience. So basically, you'll be able to take the complete LumenRT Live Cube, and once you place the Oculus Rift or the HTC Vive headset on your head, it will automatically switch into immersive mode, and so it'll be like you're walking around directly inside the Live Cube. So you'll see the full things like clouds, water, and weather, breeze animated vegetation, moving cars and vehicle. You'll be able to change the time of day, and you'll get this very rich, high fidelity photoreal cinematic imagery. The second thing we're working on this right now as we speak, is to provide a very rich interaction model inside the VR experience. So when you're walking around and you're looking at your models, you can actually do things like, okay, now I want to switch my point of view to this car running down the road, and you'll be able to switch, and it'll automatically take you inside the car, and you can see what it looks like from the car's point of view. Or you can say, I want to key in an address and go to this particular point of view on this building on the 7th floor and look out exactly what that point of view is going to look like. You'll also be able to click on various objects and have them pop up BIM information. So if I'm working on a road and there's some steel structural member, some guardrail, I can click on that and it will give me all of the BIM attributes for that guardrail. We're also going to provide a user programmable set of input and output to the VR device, so you can actually hook up other devices. So for example, we have a customer right now that's working with a LumenRT Live Cube using a driving joystick. So they have a drive, what is it? It's the Microsoft driving simulator, and they've actually hooked up a simulator directly to the Live Cube. So the bottom line here is we're not only going to provide what you can see inside of the LumenRT Live Cube, but we're going to provide a rich set of capabilities for interacting with that information inside the Live Cube. Okay. So with that, let me show you exactly how this works. So I'm going to actually go and create. So this is a Live Cube here. And if I want to now take this and then generate some VR media, what I do is I go into my timeline editor and then say, okay, I'm going to create a movie clip here. And then I'm going to move to this point of view, and then I'm going to move to this point of view. So I've quickly created an animation here. Okay, so then I can play this. Okay, and then now what I can do is I can actually go here and then output this as a VR video. So I just say export clip. And then I can indicate, you'll notice there's a new setting here that says I can output either standard video, which is flat video, or 360-degree VR video. And then we have some choices on the video encoder, and you can actually indicate that I want it YouTube compatible. When you indicate YouTube compatible, it will output an MPEG file and will inject the necessary metadata so that when you upload it into the YouTube website online, it will automatically have all of the data attached to it to tell YouTube that indeed this is a 360-degree panoramic video. So I'm just going to create one here really quick. I'm just going to make it a very low res one. I'm going to make it like 5. I'm just going to do 10 frames a second. Okay, so I'm going to say okay. So basically what it's doing now is it's creating all the frames. You remember that sort of cross strip map that I showed before? This is actually what it's doing. So it's creating each one of those shots, top, left, bottom, right, and front, and then combining them together into this equirectangular image. And when it's done, you'll see a complete equirectangular video generated from this. And you can output these in a variety of resolutions. We recommend that if you're going to share these with people online, that you output this at 4096 resolution. That's currently the highest resolution that YouTube supports online and what most players can handle. Okay, so now if we wanted to, I can play this video. Okay, so you can see that this video, you can see it's got this sort of panoramic look to it, but you really can't understand what's going on here, and you won't unless you're playing it with a player that understands this. So I can go say, open with VLC Media Player. So here it is inside a VLC Media Player. Now I'm just rocking around and moving around. Okay, let's take a look at some higher fidelity versions of that, and then I'll show you how to do this on YouTube. So let's go into my VR videos, and let's close this. Okay, so now I've outputted some of these videos. So here's let's take a look at the Bentley project here. So I'm going to open this with VLC Media Player. So now I'm sitting inside of this outputted 360-degree video, and I'm just moving with my mouse to look at various points of view. I can zoom in, I can zoom out. Okay, if I zoom all the way out, you'll see I'm going to zoom out all the way to a world here. Okay, so now let's zoom back in. Okay, so you get the idea. You just generate your live cube, whatever you're authoring, and then output the 360-degree video, and then put it in a player either on your desktop on VLC Player, or if you want, I can go to YouTube over here, and let's take a look at the same thing on YouTube. So I'm going to click on this, and then go here to another tab. Okay, so here's the same thing on YouTube. So I'm going to do this at full screen. So now I'm running directly on the YouTube player, and you can see the identical thing that I showed you with the Videoland player. So to upload these videos to YouTube, it's very, very simple. Once you create a YouTube account, you just upload the video as you would in any normal video you're going to upload to YouTube, and because you've injected the metadata inside of LumenRT, which is done automatically, it automatically recognizes the fact that it's a 360-degree panoramic video. So you're all set then. We've got some other ones here. Maybe I can show you. So let me close out of this one, and let's play. Let's close this, and let's open. Here's a roundabout from the Washington State DOT. You've probably seen this model many, many times, but I'll show you what it looks like. Here, let's close out this YouTube. There we go. So this is the roundabout that Kirk and his team created over there. So you can see I can, pan out. You can see it's just you can see the equirectangular nature of this. Okay, let's take a look at here's the G.1. So these are really nice to take along to public involvement meetings. Customers can look at this thing, or your users or your clients or citizens or the zoning committees, whoever, and they can get a much better idea of what this project is going to look like in the context of, the city or, the existing landscape there, and they can move around freely. So I can turn around this. It's like I'm operating in the car from reverse. You can also use these. We've generated some very, very high fidelity versions of reality meshes. So this works well with the reality mesh and this new scalable reality mesh that's available in LumenRT. So here's an example of that with the city of Philadelphia flyover we did. But I mean, the detail on this is just amazing. I mean, if you look at in here, this is a single reality mesh that we created with a flyover and a helicopter taking photos and then converting those photos into a very detailed mesh. And you can see it's just stunningly beautiful. The detail on this is just incredible. You can also use it for things like night scenes. So here's the night scene. Okay, so here we are. You can see that the lights are flickering, and we've got the cars with the lights on the cars. So there's a wide variety of uses and applications you can apply this to the road and rail space, and we think that VR provides you just another arrow in your quiver in order to tell a more compelling story about what you're trying to do with your design. So with that, I'm going to switch over to here, and then we'll take any questions or comments you might have. Okay, so